Good evening. Welcome to the special Nobel session. I'm going to give a little bit of context historically and maybe some information because I've encouraged Michael and Mike just to be entertaining and not be serious tonight. And so we hope we're going to have a really good time. So, I mean, all of us know the really classic paper by Ron Konopka and Seymour Benzer that really kicked off the modern era of the genetics of circadian rhythms. And so that was in 1971, and I'm not giving you an accurate historical timeline here, just to be clear, just a few highlights. But obviously, one of the most important events was the identification of the period gene. That was done in a series of papers from both Michael Rosbash and Jeff Hall's lab and Mike Young's lab, independently when they were competitors. Okay, they're sitting next to each other now, so. Right. Michael says he's mellowed in his old age, but we'll see tonight if that's true. But anyway, what's important is they first physically mapped the region, okay, initially in these papers, and then later they rescued the behavioral phenotype, and that really proved that the locus was contained within those fragments of DNA. I would say the next really seminal result was the discovery of negative feedback of PER. I'm skipping a lot of little details here. And that was really this paper by Paul Hardin, published in Nature in 1990. It might have been press-edged by some work on the protein by Kathy Sawicki, and then later measuring transcription and showing the rhythm was really transcriptional, again by Paul. And so this led to the really critical idea that PER was in an autoregulatory feedback loop. And so this is really the design or the logic of how the oscillator works, negative feedback, autoregulation. And that really stems from that Paul Hardin 1990 paper. Now, PER, of course, doesn't work alone. Mike Young's lab then discovered, Amita Skal, Mike Myers, the partner of PER called Timeless. And I didn't put all the papers up here, but they also cycle. And importantly, a number of groups, there are actually 4 papers, I didn't put them all up here, in '96, that showed that Timeless was degraded when the folies were exposed to light in a post-transcriptional method. It was a degradation of the protein. Okay, so I would say these are really the key initial findings. Really, the discovery of the 2 major repressors, PER and TIM, and the autoregulatory feedback loop, and also some idea about how light might entrain or synchronize this molecular oscillation. Now, at this time, in the 90s, Gene Block actually started an NSF Science and Technology Center. And we initially had Mike Young in the center. This is based at UVA, University of Virginia, Northwestern, Rockeller. And then I convinced Gene to recruit Jeff Hall and Michael Rosbash into the center so that we could corner the market on Drosophila. And so we succeeded in that. And then Steve Kay turned Arabidopsis into a genetic organism, both at the reporter gene level and then by doing EMS screens, found the first mutants in Arabidopsis. Many of the other chromosomes were screened in flies. I'll show you some of the mutants that came out from this. And at Northwestern, this allowed Fred Turek, Larry Pinto, and myself working with Bill Dove to work on mouse screening and cloning. And so these are just a few of the highlights that came out of this Science and Technology Center during this 11-year period that it existed between 1990 and 2001. And it's really quite remarkable. Beyond, I would say, correct me if I'm wrong, Mike and Michael, that the majority of the additional mutants after Per and Tim were actually found in screens supported by the center. Double time, Vril, clock, and cycle all came out of these screens in flies. And of course, it allowed us to also work in Arabidopsis and mouse. This work was never supported by the NIH during this period. Sorry, Mike. It was too out there, too risky, high risk, you know. So anyway, so we're really grateful to Gene Block, who really led the effort to actually obtain this center. There are only 3 of these technology centers in all of biology supported by the NSF. It was quite remarkable at the time, and it made a huge difference for our field, I would argue, because many things gelled during this decade. Okay, so this led eventually to this model of the fly oscillator, which I don't know if you guys are going to talk about, but this is a slide I got from Michael's talk a long time ago, and it really shows most of the major steps that are still true today, even though this slide was made in 2000, 18 years ago. Okay, so just show you a little clip from
I think a really important
Ron
aspect is
Konopka,
how the
since
human
some of you
clock
may have not met him.
is related to the other mammalian and the fly clock, because the Per gene is there's actually 3 copies of it in humans. So evolution, for some reason, has chosen the Per gene to utilize in the higher organisms, and of course Per is also found in the mice and the hamsters. So the question is, how do the human clocks then differ from the other clocks? And then we can start to address human disorders.
So you can see that Ron was already thinking ahead at that time. He was prescient and foreshadowing where the field is today. So then the next part is really the golden era for the trio. This is one of the early prizes they collected. It's the very prestigious Gruber Prize in Neuroscience that was awarded at the Society for Neurosciences in 2009. And I had the good fortune of being able to celebrate that with them. You can see that maybe Michael and Jeff are having a little disagreement here. I don't know. And then, of course, the reason we're here tonight, the ultimate 2017 Nobel Prize, all 3 of them. As I was preparing this talk, I, actually decided there really was quite a body of work that you guys did. And that maybe the Nobel Prize Committee was correct. Anyway, so I think, in retrospect, extremely well-deserved and extremely good for our field and into the future, we hope. So since Jeff couldn't make it tonight, I thought I would share a few things about Jeff. These are 2 pictures that I got from Bambos. This is Jeff. Everybody knows that Jeff loves dogs, and he loves the Civil War, okay? So these are really emblematic of Jeff. and I thought you should hear it directly from Jeff
Unexpected in
himself.
general terms, especially unexpected for somebody who's been out of this enterprise of basic biological research for 10 years. We owe a lot. All three of the awardees owe a lot to how the fundamental factors and phenomena were established by many, many investigators going back more than 100 years, without which we could have done nothing. You probably think you have a constant temperature as an advanced mammal of 98.6. That's totally false. Your temperature is changed, your internal core is changing all the time, every day, all day. It peaks or plateaus around midday, it sinks downward and bottoms out in the middle of the night when you're asleep. Nobody knows, nobody cares. If you try to describe what you do for a living, if you're studying, I can say to you, oh, we were studying the macromolecules piled up at presynaptic nerve terminals. Snore. What the hell is that? Don't want to know. If you tell me more about that, I am going to be so bored I'm going to commit seppuku. But if you say, oh, we study daily rhythms, like behavioral rhythms, for example, and they say, oh, I know what that is. That isn't all that near the arena of authentic bio-gibberish. You know, I can't pour some of the money back into my research because I haven't been doing research for years. I'm retired with dwindling coffers, so I've already lasted longer than I intended. This will keep me going until I'm dead. I do realize that nobody lives forever. It's hard to believe, but it's true.
So that was quintessential Jeff. And I'm going to now turn the podium over to Mike Young, who's going to go first, and then followed by Michael.
So I'm back in my home state. I was born in Miami. I thought I'd give you a little bit of background for what it's worth. My parents were risk averse. They met in Tennessee and went to Miami for their honeymoon and decided not to go back. So I don't know whether they thought they could just live off the sea, which is sort of what you see here. That's a lot of fish. But at any rate, that explains why I didn't grow up with all my relatives in Tennessee. We were quite isolated down in the bottom of Florida, and I can illustrate some of this. This is my kindergarten class. You can see this snappy dresser here. How do you like that? How do you like that bow tie? I was a Southern gentleman, I guess. At any rate, I realized looking at these pictures just how small the community was. There just weren't that many kids. In fact, if you look at the faces here, you'll notice that about half the guys in my kindergarten class, for example, this guy here, in addition to me and a couple of other guys, are on my baseball team when I'm like 13 or 14 years old. So here's that guy standing tall. Let's see, this guy was in there, and this guy was also in my kindergarten class. So you can do the statistics. If you've got half of a kindergarten class on the baseball team, for all of South Miami, there can't have been too many kids. At any rate, we had a hard time finding people to play baseball with. And they would ship people in from out of town. Luckily, we didn't have to play anybody out of state. We might have had to play guys like, instead of the Tracers, the Flies. And these guys are on their best behavior, you can see. And their coach really was responsible, I think, for this bad behavior. This is an example. Michael knows this. This is a note that Seymour wrote to his 3 colleagues, Wolf, Minot, and Jacob, in 1965, where, well, you can read it yourself. Dear colleagues, basically, dear colleagues, I have to put my glasses on to read it myself. Please accept my sincere condolences on the occasion of your being forced to share the Nobel Prize with those other 2 jerks. When in my opinion, you alone fully deserve it. Now I know, and of course the same letter was sent to all 3 of them. You just scratch out whichever pair of names you're least interested in. Now, I know Michael knows this story. He's spoken about it, but what Michael might not know is that Seymour got a reply. Dear Dr. Benzer, you alone understand, just as I alone deserve the prize. And, not even signed. So bad behavior begets bad behavior, I guess. This is a picture of Ron. I showed this a couple of days ago as well. Ron sitting with many other members of the group in 1971. The other photo was a little earlier. And this is just a couple of months after he published his paper that Joe had already mentioned. Certainly the beginnings of my involvement in this field. When this paper came out, I was a brand new graduate student at the University of Texas, and I look much as I do now. Actually, a lot like those guys in Seymour's lab. We couldn't get our baseball caps on. But I spent most of my days at the University of Texas chained to a photomicroscope looking at chromosomes. These are polytene chromosomes extracted from the salivary glands of the fly. And I was looking at this area of Drosophila X chromosome, which is blown up down here, which had been studied quite intensively by myself and others before me in the lab. And Ron had by recombination mapping, found that his mutants fell somewhere in this general interval, perhaps even in the area that was so well studied. And this is just a drawing from a paper that I published in 1978 that summarized some work that I'd done that included mapping the period gene. At the time that Ron's paper came out, I was interested in how information is packed into this region of the chromosome. There is enough DNA in there to encode about 25 times as many genes as you could find by classical genetics. And in fact, it seemed that each one of these striations, these chromosome bands or chromomeres, seemed to correspond to a single vital gene. And we were quite interested in how so much DNA could be involved with so little information. Or did this mean something was very different about eukaryotic genes? So what I was doing was trying to come up with measures for addressing the question of whether we'd missed, whether genes had been missed. Of course, if you're screening for lethal mutations, you can be sure you're not going to miss vital genes, but things that affect other aspects of the phenotype you could easily overlook. And so PER was attractive to me not only because of the interesting behavior that it provided, but also as a means of determining whether it would be one of the exceptions that I was looking for. And I generated a method for producing chromosome rearrangement breaks in this interval just based on the fact, the presence of the break, not based on a visible phenotype, which could then I could go back and ask whether or not the break produced a phenotype. And in fact, a number of mutations that I studied deficiencies and this translocation, for example, had all been assumed to fall between two lethal complementation groups. For example, this translocation, T14JC43, which joins the tip of the X chromosome to the base of the fourth and vice versa, seemed to have no phenotypic effect. It was just what we would call a non-essential breakpoint. But in fact, all of these rearrangements, all these deficiencies in that translocation, all fell to either side of the period locus, and JC43, in fact, broke the gene. It was a per-mutant. It was an arrhythmic mutant, very similar to the original per-O mutant, which I never would have known had I not had Ron not sent me the mutants to map and work with. Ron was very generous in that way. You'd ask him for reagents, and of course there was he was very much in the spirit of genetics in those days, that you share your published reagents. So this, of course, became very valuable, I think, not only to us, but also for Michael and Jeff, because in 1983, if you're going to try to do a chromosome walk through tens of thousands of base pairs of DNA, you're not going to be able to find point mutations, but you can find chromosome rearrangement breakpoints, and that can lead you to the location of a gene. So I do want to correct one thing that Joe said, which is that I do think some gratitude is owed the NIH, at least from me. I was an NIH trainee as a graduate student at Texas, and then I had an NIH postdoctoral fellowship. My first NIH grant arrived when I got to Rockefeller 3 months after I arrived. That is hard to happen today, but I've had continuous support from NIH ever since. So they did. If anyone came up short, it would be Hughes and not NIH. This is me when I arrived at Rockefeller. I'd spent a couple of years in California with Dave Hogness's lab at Stanford, where it was the only place to go to learn about recombinant DNA and Drosophila. In fact, it was the only lab I applied to. That's in retrospect, a dangerous move, but it somehow worked out. So I spent a couple of years in Dave's lab and learned all about these fascinating and phenomenal tools that recombinant DNA had brought on board, and started collecting people to go after a couple of genes. Half the group was after a gene called Notch, which was involved in neural development, neuroectodermal development, and a couple of the people in the lab working on that project. This is the back of Simon Kidd's head. I think this is Vicki Corbin, this is Peter Bingham, and we were, so that part of the group was cloning Notch, and the other part of the group was Ted Bargello, who was the lead effort on trying to get PER out, again using those chromosome rearrangements to inform us with regard to where we were in a long chromosomal walk. Here's another picture of Ted with his buddy Jeff and Leslie Vossall. And who's this? Is that a lot of hair? Bambos is there as well. And another picture of Jeff with Mary Bayless. So this is sort of the beginnings of work in our lab. Leslie was known for changing her hair about once a month. So this is Leslie 1 month, and this is Leslie another month, and this is Leslie on the left yet. So, and Leslie, of course, is now a professor at Rockefeller and still does this. I think this is the back of Mary Bayless. They're making food. In those days, we didn't have a centralized kitchen. We were the only Drosophila lab at Rockefeller, and so we had to make our own food, at least for a while. But we were thankfully joined later and got a pool going. So this is a machine that we had built in the Rockeller shop to do our first assays. You can clone a gene, you can stick it back into flies, but if you can't find out what the effect is behaviorally, you're not going to get very far. And so we told them what we needed, and they built this 5-element huge box. It's about so big. You have these far red light emitting diodes on one side and phototransistors on the other. And you know the drill. You have a big tube with fly food and a fly in there, and it will break those beams, and you'll get records out that look like this. So these are some of the very first records that we got from a fly that was transformed with a plasmid carrying 7 kb piece of DNA that could encode this RNA that had been broken by the JC43 translocation. And what you see is that if we take Ron's original PERO mutant and put that transgene in, we get rhythms back. They're long period rhythms rather than wild type rhythms, which are down here. But this is what PERO looks like without the transgene. And we also found that we could make a synthetic deficiency using the rearrangements and eliminate 10 or 15 kb of DNA around PER. And putting just PER back in, the 7 kb piece of DNA back in was sufficient to restore rhythms, just like we restored rhythms in the PERO mutant. So that more or less nailed down what PER was and what it made. And at the same time, we were doing occlusion assays, and these are some of the, so far as I know, I think this may be the original hand-wrought occlusion data for PERO controls and PERO transformed with this transgene, which we called P1.48C. And what you can see is the lack of rhythmicity in the controls and the return of rhythmicity that came from an occlusion. And of course, these are, in those days, we didn't have a facility to collect. It was just Ted and me, and we would take turns coming in the middle of the night and making those collections and plotting them for day after day after day, but pretty convincing data nevertheless. And so all of this, of course, was written up at the end of 1984 by us, and of course, at the same time we were doing this at Rockeller, Michael and Jeff were on much the same path at Brandeis, so these things came out together, and I think we got to talk about this the following summer at the Gordon Conference that many of you probably recognize your faces here. I think Michael's right here, Jeff's next to him. I think I'm down here somewhere, and Ron is also down here. I think it's hard to see from the side, but down there on the front row. So that was an exciting meeting for us. I think everybody sort of believed at that point that genetics could do something for the study of circadian rhythms. Of course, one gene is, there were tremendous advances that Michael and Jeff found from looking at the kinetics of production and establishing a feedback mechanism. And of course, we had at that point taken off on these horrendous screens. You know, Ron had found the original permutation in the first 200 flies, and he screened another, I think, a total of 2,000 to get all 3 mutants. And unfortunately, I think someone overheard Ron say at one point that his Konopka's law, I think it became, if you don't find it in the first 200, quit. And I think that sort of, many people took that to heart, but luckily Amita Segal and Jeff Price hadn't heard of Konopka's law, and so they decided to screen for new mutants and went through 7,000 bottles of flies. And of course, it takes many more than 7,000 bottles of final tested strains in order to make those strains to be tested. So I can't even, I couldn't get a picture. This is a Photoshop picture as it is, and I busted the Photoshop program if I tried to show it all. But actually 2 mutants came out of this, Timeless and Double Time. The first allele of Double Time came out of this. And lucky to catch Jeff Price and Amita, who did that work in Stockholm last December. This is Jeff, who's here, and his wife, and Amita having fun in Sweden. So I'll tell you a little bit about the experience of going over. This is my wife Laurel and myself showing up at the museum. That was, I think, the first day we arrived. After we'd had a chance to sleep, get up in the morning, they took us all over to the museum. And what they wanted us to do is to sign the bottoms of chairs, or a chair, that they put in the cafe. And I then realized that I'd been sitting on Barack Obama earlier in the day, and so I went back. Yes, that's Barack Obama. And so as you see here, the three of us signed. Michael and I put our names down in medicine 2017, and of course Jeff, in his usual style, says Jeff Hall ditto. Are you surprised? You know, I don't have a picture of it, but when we visited the Nobel at the Karolinska, they wanted us to sign a poster that they had in the meeting room where they held their deliberations, and Michael and I willingly signed, and all Jeff would do is put an X and walked out. You know, so in the museum, we had sent over. They wanted artifacts, and I had sent this original locomotor monitor and records that came from Eclosion. And Jeff and Michael had sent their original locomotor monitor and some original locomotion data. So this is now sitting in a black box at the Nobel Museum, which was kind of cool. Ever the commercial angle. My daughter snapped this picture within days. They're selling necklaces that are supposed to be the timeless protein. So if you didn't know what it looks like, and I really don't, that's what it looks like. And I'm sure it's accurate. It's $25, so it ought to be accurate. So, about a day later, in order to go forward, you have to give a lecture. It's mandated. And the three of us are in this stadium-size auditorium, and for some reason, I don't know if they're trying to keep us apart, but they stick us in the middle of this crowd, and then, somebody in traditional garb comes and gets you and leads you in a 5-minute walk up to the stage to give this talk. So we all gave our talks. This is after the three of us had presented, and as you see, they awarded this. They're really supposed to be limited to 3, but they made an award to 4 laureates this year. And I don't know if you've seen any of the movies of this online, but Jeff kept wandering back into the trees. So this is after the lecture. There's Paul Harden, and Dragana Ragulja, who were over for the event. And I can't even. There were so many things coming one after the other. They give you a little pamphlet. And, it tells you minute by minute what you're going to be doing, and after a while you just give up and follow somebody around. But on one of those early nights, we had this concert. This is my wife Laurel and myself at the concert, and then, of course, they take you to this palatial dinner after the concert. This is Anna, our attaché, so she's whenever I got confused, I would just ask her where I'm supposed to be next, and she would know, and I never would. And we had a few parties. This was one that Adam Claridge Chang put together. These are members past and present of the lab. This is Monica Roth, Lino Saez's wife, and there's Jeff and Amita again. And some of you heard me talk about Sophia's work and Zakun's work the other day. Alina Patke, who works on human rhythms and DSPD, is over on the left. And here's Leslie with long hair. And Leslie, I mean, what can you say? So Leslie built this hat, right? And I still find it remarkable. It's extraordinary in every way. This is before the ceremony, and this is me. I actually have been given this prize. That's Laurel, my wife Laurel, daughter Arissa, who's a resident at Vanderbilt now, and Natalie, who's a graduate student at Penn. But I became very disappointed because they took it away. Anna's trying to explain to me that they're going to give it back, but only after a few days. And you can see the look on my face is doubting. And that was about a 5-minute conversation that went on. So after that, we're off at a banquet, which was in the City Hall, which was about 5 times larger than this room, would you say? I don't know. You felt like you were in a castle. It was sort of a castle. And those receiving the prize were scattered amongst members of the royal family and committee in this center dining table, and then you had just hundreds of these things coming off to the side. I can't even imagine how many people were there. I didn't get a count. But I think Michael and I are down here somewhere. You may be able to see it. I can't see it from here. And these were all made of ice with an LED sitting on them to make these mysterious lights. This whole thing was put on television in Sweden, and we were told, Anna told us that families all across Sweden would sit at home, put this on TV, and have their own little banquet going on. And this is the kind of clip that they would put together for the presentation of these across Sweden. And here, of course, Michael and I are chatting away, and just down the hall, or just down the table, here's Jeff confusing this person here. Okay, I'll just show it. Let me just wrap up. So while we were in there with that banquet and the ceremony, we had about 30 other people that had come over that we couldn't get tickets to get in, and they had a parallel party. Here they are looking somber as they watch what's going on in another room, but as you see, they look better than we did, I think. All of that was followed by a series of strange events with medical students that had lots and lots of medals, and Michael and I complained loudly, where did people as young as you are get all those medals, and why? And so then we apparently irritated them enough that they pinned us up with medals. Here's an example. And I did finally get things back, as Anna had promised. And then after all of that, Michael and I took off to see Nobel's house in the country, and we got to have dinner with Alfred Nobel, who here was very interested in my iPhone. But I'll just close by pointing out that I was amused when this came out, that this thing in the Fort Worth, Texas paper, we moved to Texas when I was in high school, and I'm apparently claimed by the high school after all of this, but I think at the time I was there, I wasn't regarded quite as well. I think I was mostly thought to be, if I shake this one more time, the whole school goes. I mean, this is not exactly what you think would do the trick. Anyway, thanks very much.
All right, well, a hard act to follow. I'll do my best. So let me begin with the phone call at 5:10 in the morning on October 2nd. And perhaps I should really begin the evening before, about 10:30 at night, when we're going up to bed. And of course, everybody knows the first Monday in October, that's the Nobel announcement. So we're going up Sunday night to bed, and I said to my wife, I think I'll bring my cell phone upstairs. And and she said, you're an idiot, which she says quite frequently. And on two accounts. Number one, they're going to use the landline, and number two, more importantly, your time has come and gone. She said it's been 5 years since you guys have won anything, and immunotherapy, CRISPR, give me a break. So the phone rang, much to my shock, at 5:10 in the morning, and I said to Thomas Perlman, the head of the committee, when he said, you've won the Nobel Prize, I said, you must be joking. And he thought this was great, and he even mentioned it at the press conference, and I tried to explain it's a way of an American getting a little space, getting your breath, but he thought I really meant you're joking. And then I had to give him Jeff's phone number, because Jeff is a recluse in all senses of the word, and there's only about 4 people in the world who have his phone number, and I'm one of them. And so it's 5:10, and I'm fumbling for my contacts and my phone when I'm half asleep, and so forth and so on. So we go downstairs to make coffee, and he said to me, he said you're not allowed to tell anybody until the press conference at 11:30. So it's now about 5:16, 5:17, and there's 12 or 13 minutes left until 11:30 in Sweden. Who am I going to call at 5:16 in the morning? In any case, we go down to make coffee, and at 5:30, exactly at 5:30, my cell phone rings. And there's a name pops up on my cell phone. You know how you have lots of contacts who are people you haven't talked to in years, who you happen to have put into your cell phone. And it is a Boston scientist, a Nobel Prize winner from more than a decade ago, who every morning on the first Monday of October wakes up at 5:30 to see who has won the Nobel Prize. And I thought, this is the most absurd thing I've ever heard. He's already won the prize. Why would you wake up at 5:30? In any case, he calls me and says, congratulations, the very first contact I had. So there we are. And so what I want to describe a little bit for you is this phenomenon, which is, of course, as the syndrome is defined, a feeling of trust or affection for your captors. And what does this mean? A bit strange, of course, for the people who've awarded you this prize. And Mike alluded to this, and Sheckman had clued me into the fact that you really do what they say for those 8 days, 2 to 3 events a day. You're on stage all the time, and it really is, you do exactly what they say. Having said that, in the course of those 8 days, I went from being totally ignorant, and in fact, if anything, a little cynically dismissive about this organization, to realizing how hard they work and how hard they try to get it right. It isn't that they always get it right, and I'm not claiming they got it right in this case. But the point is that you can imagine this has been going on since 1901. And if you had this sitting on your shoulders, you would really, they are the hardest working prize committee I have ever seen. And it's just this incredible, I also knew very little about Sweden despite having been a tourist once or twice. So this is an incredible country of 10 million people. And it couldn't be more different than the United States. I mean, at every level. Of course, the scale is different. They're highly taxed. Almost nobody accumulates capital. They trust their government. They feel they're getting something back for their taxation. It's a flat landscape educationally as well as economically. It's just absolutely remarkable. And so, as the little fly on the picture that Mike showed you this is a dessert that friends of ours, a week after the prize, we went to dinner at our friends, and they had ordered this cake for everyone there, and in fact, at my press conference that day at Brandeis, that's really what I said. It is a great day for the fruit fly, and it was a great day for the fruit fly. And the reason for this is because this is the 5th Nobel Prize for the fruit fly, beginning in 1933 with T.H. Morgan. And I did not know until we went to the Swedish embassy in November in Washington that T.H. Morgan was also the first American to ever win the prize in physiology or medicine. In other words, this was the 33rd prize that had been awarded in this discipline, and no American had ever won until T.H. Morgan. And then Herman Muller, 1946, Nusslein, Volhard, Wieschaus, and Lewis in 1996, I believe it was, or 95, thank you. And in 2011, Jules Hoffman is part of the Innate Immunity Award. And so one of the perks that came with this prize for me was going on Wait, Wait, Don't Tell Me, the NPR show on Saturday morning, and you acquire great respect for these people when they become adversaries. And I should say Mike Young falls in that category too. And just to elaborate on Joe's comment about being competitors at the beginnings of this journey, I turned to Mike when Joe said that, and I said, you realize, of course, that we have a burial plot for you next to me, and that we're gonna end up right next to each other. So at this show, when I said on the radio that this was the 5th Nobel Prize, Paula Poundstone, who is, just sheer brilliance, said immediately like this. She said, "Those poor little animals, 5 of those heavy gold medals around their neck. How do they possibly manage?" So, we are. This is the letter which arrived at home. I think in December after we came back from Stockholm and from our president, and this was the first time in more than 16 years, that is throughout the entire Bush administration and Obama, that a phone call had not gone to the Nobel Prize winners from the White House on the morning of the prize, nor were we invited to the White House. Both of those had been in operation at least for 16 consecutive years. You want to say no thank you, right? That's a... Actually, one could go on and on. I had my, we were talking about taking a knee in the White House, wearing my No to Racism T-shirt, so anyway. So you all know this. I'm not gonna say much more about it, other than to emphasize the fact that this prize is in physiology or medicine, not physiology and medicine, as even I thought until the fall of 2017. And the head of the committee was asked at the press conference by a journalist, 20 minutes after the announcement, what has this done for medicine? I don't understand why this prize? And she pointed out the distinction between physiology or medicine. And so I think you have to be incredibly lucky to be standing up here. And one of the waves for which we're not responsible is we were just standing in the right place when the wind swept by, that probably the committee realized that basic science is under attack, and we'd be good representatives of the foundation of all applied science. And so I want to point out, actually, this sort of got out of order, but in this context, this comes a bit from a discussion I had with Carl Johnson a couple of weeks ago. We really are now the old guys. And of course, it was only yesterday that we were the young guys. And that's, of course, what happens in life. You blink and you've gone from the young guys to the old guys. And my congratulations email from David Baltimore on the morning of October 2nd, I think really captures that essence that the people who are gone eulogized, at least some of them. Yesterday, they're shooting at us now. We're on the front lines. So, speaking of this age issue, it's perhaps useful to point out that 8 of the 10 2017 winners, including the 3 of us and the physics winners, one of the economics winner, one of the chemistry winners, we're all senior, let's call it. And I think the point here is that this really reflects the age in which we were raised, both in the 50s, Sputnik, and then as scientists. And we owe an enormous debt to the founding agencies, as Mike and Joe indicated, for continuous support of basic science. And I should say I showed this slide and made this point in Argentina about 3 weeks ago. And after the talk, and there was a whole traumatic event associated with the visit to Buenos Aires, a woman came up to me afterwards and said, I liked your talk, it was great, but you should have said something. Why didn't you say something about the fact that you were all male when your wives were home taking care of the children and cooking and cleaning so that you could achieve something in the laboratory? And I said, because I didn't think of saying it, but it's a good point. I take your point, and hopefully in 20 years, if there are still a large numbers of winners, all this will change. So both Joe and Mike mentioned Ron, and I'm not going to say anything more about it in light of that. I will say that I owe an almost unique shout out to Paul for his contributions to my work. I should say that giving credit to students and postdocs should be automatic, because nobody believes it anyway. Uli Schibler pointed this out to me. That is even when it's true, and I will prove to you it's true in this case. It's the right thing to do, and sometimes it is absolutely their work. And in this particular instance, Paul had the perspicacity to not give up when you couldn't see cycling using total fly RNA, because the body is too contaminated with transcript, which doesn't undergo any oscillations. And so the amplitude, the cycling amplitude, is too low to be credible. And he said, let's try it with heads. And when you do it with heads, it turns out to be absolutely credible. And so that point not only is to give credit to Paul, but to illustrate how a very small change in protocol can make all the difference between success and failure. So, you know, you in some way, that insight and that courage of Paul's is what gave rise to the feedback loop and what gave rise to this whole enterprise, at least from my standpoint. And so the Nobel Committee recognized this in this little paragraph here, which I think I'm going to skip in the interest of time and the fact that the principle is obvious. I do want to show that this gel that Paul gave me as a present when he came to the party we had at Brandeis, which is the original gel. And I should also point out that this is before the era of PCR, and so this was done by RNase protection, and turns out not to be so hard, but not to be so trivial either. And so, you know, another little subtlety which makes a distinction between failure and success. And so here we are with the conserved core of the negative feedback loop. This period, 1982 to 1998, is actually the period that was cited by the Nobel Committee. And I should point out that was it SRBR or a Gordon conference in 1998? I think it was SRBR, when all this information sort of coalesced and came together. All these genes had been cloned. Everybody was really so excited, and the basic foundation really had been laid. And so I'll show a few pictures. Yes, one more point here, and that is to say that Joe was incredibly gracious, but everyone in this room should realize that not only did many other people contribute to this simple sort of feedback picture, but some of them could be standing here instead of me or Mike or Jeff, and so it's really, you know, just a little silly nanometer that has one person receiving this and someone else not. So this is a picture of Paul and Susan, who's here, his wife, and Isaac Edry. He I think being in my lab for a few years drove him to Orthodox Judaism. And Joan Rudula, who was really responsible for having her feet on the ground the whole time and doing this and organizing this screen that we did in the genetic screens that gave rise to Clock and Cycle and other things as well. So this is a picture of the ceremony in Stockholm, and I show it to tell you that I, and it turns out Rod McKinnon, with whom I had a conversation about this, had this gut-wrenching attack of imposter syndrome when sitting in that chair, because you realize that Albert Einstein and Madame Curie had been in these chairs, and you think, what the hell am I doing here? And then both of us comforted ourselves, you know, several years apart and independently, with the notion that, wait a minute, I didn't choose me, they chose me. This is not my responsibility. So Mike mentioned the Nobel Prize, the Nobel banquet that night from City Hall, and this is the number, Mike, of people that are in the banquet, 1,300. I asked because I also had extra people there who wanted to go to the banquet, and I, you know, in my typical very elliptical manner, asked the woman who was in charge of orchestrating events whether there was a black market and could we buy some extra tickets, and it turns out to be an incredibly difficult ticket. Everyone in Sweden wants to go to this thing. So 300 people. There are 250 waiters, and there's a competition in Sweden to be one of these waiters. And if you divide 1,300 by 250, you get about 5, and they serve everyone synchronously. So the 1,300 people, the food goes down in everybody's plate all at the same, each course, all at the same time. So it's really quite extraordinary. I want to say a word about the head table, and which Mike also showed you where we were sitting, and something about the king. So the king sits at the head table, and in the course of the many emails that went back and forth in October and November before we left, one of them came to us and said, I want to point out to you that there's plenty of time between the ceremony and the banquet at City Hall for all of you to go to the bathroom, to go to the toilet. And I said, excuse me, WTF, more or less, And so it turns out that you're not allowed to get up from the head table until the king gets up. So once he sits, it's a 4.5 hour, it's a 4.5 hour ceremony, and you appreciate the fact that there were 10 old white guys, there, and so for 4.5, and there's a lot of alcohol, and so you 4.5 hours. So I and my entire entourage discussed this by email beforehand, and then we were in a complete, this is impossible, how is, it turns out she was right, it was entertaining enough that, but we even, who is going to put the diuretic in the king's drink? and we had was this really as bad as ecstasy, and would we be okay? And so, we had a long, so this is my daughter, Tanya, and can anybody guess who this is? So I did this once before, and at Hughes, at HHMI, and Leslie Vossall, who's sitting there, says, I know who it is. I said, Leslie, you were there. Of course you know who it was. So these, the student wanting to get the answer right never disappears. Anybody know who this is? Who wasn't there? So here, see if you can see the similarity. So this is Jeff receiving his prize, and this is Jeff's brother, who was the only family member of his who came there, and is an absolutely delightful guy, and I'd met Bert, and I had met him many years ago when we were all young. And so this is Jeff in his more traditional garb, and also with his SEG. Does anybody know what an SEG is anymore? Ask me over a drink, for those of you who don't know. So this is a picture in a restaurant, and the point of the picture was that the entire kitchen staff, who by the way speak perfect English, know exactly who you are, where you came from, what you had done for work, and they want a picture, and it's just, you cannot imagine a more different scene. And so this sets the stage for telling you about our return to the U.S. So we fly back. We were on the same plane back with the Youngs to New York. The crew in SAS, actually a Norwegian crew, not a Swedish crew, how honored we are to have you here. They knew who we were. We get to Newark, we change planes, we go through, with our hand luggage, we go through security to get on our Boston flight. And my wife has the medal and the 3 replica medals, which we purchased, so 4 of these things, in her backpack, because she won't even let me carry my own passport when we travel together. And so there was no way she was going to let me actually take and then start to say, where did I put that? Where's it? So she has the medals in her backpack, and of course it goes through the medal, the screener, and the guy pulls her backpack off and starts to go through everything. And he said, he opens this up, and he says, "What's this?" And she said, "It's a medal." And he said, "What kind of medal?" She said, "A prize medal." "What kind of prize medal?" "A Nobel Prize medal." No recognition. and then he wipes the metal. He wipes the metal with the mass spec, with the mass spec cloth, and puts this in. And she turns to me, and the side of her mouth says in Spanish, she said, "The irony, the guy who discovered dynamite, they are wiping the metal for explosives from the guy who discovered dynamite." And so he finishes, he wipes all 4 of the metals, he puts them back, and he looks at us, and he said, very sarcastically, he said, "Have a very fancy day." And we had just come back from this country which prizes education, accomplishment, where they're polite to absolutely everybody, and I thought to myself, what have we done? So I'm going to try and wrap up quickly and just say, what did I contribute to this work? I stayed out of the way and didn't screw things up too badly, it would appear. It turns out that having had a second lab for 25 years, which worked on nucleic acids, and this really helped have some appreciation for the fact that a 24-hour timer just didn't make sense from a neuroscience perspective, which was where most of the field had come from. And I'm a big believer in luck. I don't believe in taking credit for things that are good. You're just lucky, and when things don't work out, don't blame yourself too much either. That's probably bad luck too. So, as Mike said, recombinant DNA came along just at the right time. Feedback loop was correct in general. We did not show that. Tons of cycling RNAs. Who knew? We had a drop to do with that, but mostly from other people. And of course, these incredible people who worked in my lab. First, the yeast and RNA people, rhythm and fly people, and I'm going fast because I really I need a drink. And of course, I put in bold here the PIs who were at this meeting, except for I added Isaac, despite the fact he's not here. And of course, I came to Brandeis and met Jeff, and it's at the interface between disciplines where really good things happen. And this was at the interface. This interface fueled collaboration between Patrick and Ralph around cryptochrome. And so let me return for a moment to Stockholm Syndrome and not only mention this point, but it turns out that in the literature it also suggests that this is part of the psychological fabric of the person who embraces Stockholm Syndrome. And I should just say that I followed a not completely straightforward career path. I had some difficulties, let's say, as a young kid. I went as far away from Boston as I could to go to college. I was very lucky to go to 2 universities, Caltech and MIT, where they actually didn't care how you behaved, unless it was really off the charts, and I was not quite that difficult. The different scientific world that Mike alluded to, you may not know, you may have read this in something I wrote, but Mike and Jeff, for example, got their assistant professor jobs at Rockeller in Brandeis with 0 publications from their postdocs, 0. You tried doing that today. And so it was really a different world. I think most, ironically, are important. I didn't get tenure in the Rosenstiel Center in 1981. I did barely get tenure in the university. There was sort of a 2-tier process, and as a consequence of that non-uniformity, the university moved me out of the Rosenstiel Center and into biology. And next to Jeff, and in 1982, 2 months later, we began our collaboration. So the moral of the story is don't be a victim. Turn, whatever happens as best as you can in a good direction, and just keep putting one foot in front of the other. And this is, the motto I have up on my, have had up on my whiteboard for a long time. those are, words I think to live by, and I try to look at them every day and think about it myself. So I'm going to try to wrap up and just simply say that my current lab is almost entirely here. I consider that a continuation of luck. I have an unbelievable family. That's my son-in-law, Alex, daughter Tanya, wife Nadja, daughter Paula, and daughter-in-law Christine, Paula's wife. We had the F2 generation in Stockholm. There's Dylan, who was almost 1 year old, and that's Sky, who's 4 years old. And let me end by just saying a word about romance. And by that I don't mean wives and family. I want to talk about, I want to just highlight the romance of science. So I think this is an incredible profession, and at a very simple level, you really don't know what you're going to find out that day, despite the fact that most days you go backwards rather than forwards. But there's that odd day when something unexpected happens, and I consider it truly romantic. And in this spirit, let me just end with the same way I ended the Nobel lecture, by quoting a poem, or showing you a short poem from Ralph Greenspan's wife, and this poem is in the back or the front of Fly Pushing, Ralph's book, and it's, "Oh genotype, oh phenotype, this kiss had better last her. He's off to see his other love, Drosophila melanogaster." Thank you very much. Go ahead.
So thank you, Michael and Mike. I do want to correct myself, Mike Sesma. I have been supported by the NIH. What I meant is they didn't support mouse for genetics, that specific aspect. Anyway, so thank you all. What a wonderful night. I love you guys. All right.